Welcome students. Some more examples in linear DE and Bernoulli's differential equation solutions. So here is one problem. Solve 1 plus y square of dx equal tan inverse y minus x dy. So by observing, how can you identify it is a linear DE? If you see dy by dx is a first order DE, but here the variable x has power 1, remaining are y terms are in terms of functions. So this is a linear DE in x with respect to y. So actually dy by dx plus p of x y power 1 equal to q of x, like that functions linear DE in y with respect to x, but it is reversely it is a linear DE in x with respect to y. How can you simplify this as a linear DE? We can write as dx by dy equal to tan inverse y minus x by 1 plus y square. By taking this minus x by 1 plus y square term to the left side, dx by dy plus x by 1 plus y square equal to tan inverse y by 1 plus y square. So this is a linear DE dx by dy in terms of x with respect to y functions. So this is in the form dx by dy plus p of yx equal to q of y, where p of y function is 1 by 1 plus y square and q of y function is tan inverse y by 1 plus y square. So finding integrating factor e power integral 1 by 1 plus y square dy, that is e power tan inverse y. Integral 1 by 1 plus y square dy, we have the formula tan inverse y. So then solution is x into integrating factor, because this linear DE have solution x in terms of y, so that we write x into integrating factor equal to integral q of y into integrating factor dy plus c. So x into what is integrating factor? E power tan inverse y equal to integral q of y. That means tan inverse y by 1 plus y square. Integrating factor is above, again integral tan inverse y dy plus c. This should be integrate. So substitution method, let tan inverse y equal to t. So both sides differentiate with respect to t. We can get 1 by 1 plus y square dy equal to dt. So that is integral e power tan inverse y becomes e power t. Tan inverse y becomes t. dy by 1 plus y square becomes dt. So again this is integrate by parts. So we get directly formula e power t of t minus 1 plus c. This is the formula integral e power x into x dx equal to e power x of x minus 1. This is the formula integration we get by integration by parts. So like that this is. Again resubstitute t with the tan inverse y, then the solution becomes x into e power tan inverse y equal to e power tan inverse y of tan inverse y minus 1 plus c is the solution. So this is very important problem in terms of solution x in terms of y. So this is a linear DE solution. Now one more problem in Bernoulli's DE. By observing, here is directly dy by dx, there is no linear term y power 1. What is meant by linear DE? There is no linear term if y has power 1. So there is no y variable as power 1, so that it is not in linear DE and it is in Bernoulli's DE. So Bernoulli's DE directly we can get the differentiation and substituting variables. This can be written as keeping right side only x term function 1 by secant y dy by dx minus 1 by secant y tan y by 1 plus x equal to 1 plus x into e power x. So 1 by secant y can be written as cos y dy by dx minus 1 by secant y is cos y. Tan y writing in terms of sin y by cos y going to cancel. Then 1 by 1 plus x into sin y will get. So right side function 1 plus x e power x. So this is a Bernoulli's DE in the substitution. So let it be equation 1, sin y equal to u variable. This differentiate with respect to x, we can get cos y dy by dx equal to du by dx. Let it be equation 2, 3. Substitute 2, 3 in 1. Substitute 2, 3 in 1. We can get cos y du by dx as du by dx minus 1 by 1 plus x of u equal to 1 plus x into e power x. Now this is a linear DE. This is a linear differential equation in u with respect to x. So where p of x equal to minus 1 by 1 plus x and q of x equal to 1 plus x of e power x. So finding integrating factor again, e power integral minus 1 by 1 plus x dx. So e power integral 1 by 1 plus x, we can get log 1 plus x. So this becomes minus log 1 plus x. So simplification is there, e power log 1 plus x whole power minus 1. We get 1 plus x whole power minus 1, that is 1 by 1 plus x. We can write, we can simplify this. So now the solution is for linear DE of 1, we can write u into integrating factor equal to integral q of x into integrating factor dx plus c. U integrating factor is 1 by 1 plus x. Integral q of x. Q of x is 1 plus x into e power x. Integrating factor again 1 by 1 plus x dx plus c. This become going to cancel. So u into 1 by 1 plus x. Integral e power x, we can get e power x plus c. Resubstitute u with the sin y, we can get sin y into 1 by 1 plus x equal to e power x plus c is the solution for this Bernoulli's DE, which is very important problem. Okay, thank you.